Hey guys, so today's video, or rather this video, I'm not gonna discuss about what was kindly suggested in the comments of the last video and discuss the FFT capabilities of an oscilloscope versus my brand new SR760. I thought about a quick video that you might find very interesting. And it has to do with a few of the things that I've found in my recent travels that I haven't been able to show yet. So, um, in no particular order, let's start with a wonderful piece of glassware, the likes of which I personally have never seen before. And let me just get it for you. Check this guy out. So this is a Soviet, I think it's a 13LO, so 13LO16A dual beam oscilloscope tube. So it has two electron guns, and I think it's an actual storage tube as well. There's a mesh in there which kind of looks like it would belong in a storage oscilloscope, but I don't seem to be able to identify any flood guns, so it might just be something else. So look at this piece of work. It's like, I think, half a meter long or something like that. So it's a bit smaller than two of my palms, as wide as they go. It's 13 centimeters in diameter. The window, the viewing area is 13 centimeters in diameter. And it's just absolutely gorgeous. I don't know what it comes from. I'm assuming that a dual beam oscilloscope, but I don't know the model. And I'll link some information about it in the comments below. But let's just take a closer look at this thing in a bit more detail. So you can see, by the way, when I got this home, which was a very nerve-wracking procedure, I accidentally smacked it, and I thought immediately, well, yeah, that's the air leaking in. There's that mesh that I've talked about inside, and it's like a tuning fork, and it keeps rattling at a very high pitch, resembling the sound of air leaking, and that was just catastrophic. Like, I was nerve-wracked for a while, but as you can see, the getters are still completely fine. There's 4 getters. This is the anode cap right here. And let's take a closer look. So we have the electron guns themselves, the cathodes. I think they're not independent, the filaments, but I think the cathodes, the focusing grids, and all the other control elements inside are completely independent. And we have 2 sets of deflection plates. So there's, of course, 2 guns. We have the horizontal, I assume, and the vertical deflection plates, and they're just beautiful. And you can see that the connection for the deflection plates are brought out to these terminals on the side, which make setting this thing down on any surface a complete and utter nightmare. I don't have a UV light handy, but this thing appears to be a very, very blue, very fast phosphorus, and just look at it. If there was ever a, like, this is the poster child of cathode ray oscilloscopes. Like, you can see every individual component in it. You can see that all this structure is tied together, like joined together with glass rods on each side, and actually in 4 sides. and the glass rods are basically the structural elements, and they ensure that there's no electrical connection between the sections, and it's just absolutely gorgeous. And of course this thing is sorry about the glare. I don't really have anything that I can do about that. Maybe it looks a bit better like this. This thing is very proudly displayed on my collection, and it's featured prominently. I will try at some point to get a couple of small Romanian made oscilloscopes or something like that, and to have them feed, like gut them, take the circuitry out of them, and feed into this, or maybe design a deflection driver, the deflection plate driver. This would be an awesome clock, but yeah, it's such a shame that I didn't find any more. There was another one, but the getters were completely white and it was broken. Right, so I'm gonna safely put this away very carefully. And that brings us to another one of these. Let me zoom out so you can see it better. Right, so this is another oscilloscope tube, and I'm pretty sure that this one is a storage oscilloscope, a storage tube. You can see there's a mesh there, and I think these are the connections for the flood guns or something like that. Although they are marked with 1, 2, 3, 4, 5, 6, I have no idea. It's again an electrostatically deflected tube, so it's a 13Li2, so the same diameter screen as the other one. And you can see the structure in here for this one is a bit more complex, so there's more focusing and probably astigmatism correction electrodes and stuff like that inside. Let me just remove the collar here so we can take a slightly closer look at the bottom end of the tube. This rubber becomes very sticky and gunky after years, so let me try and zoom in a bit more. Apologies if the quality of the video is not going to be exceptional, but shiny glass rods again, vertical and horizontal deflection plates, or rather the other way around. I'm pretty sure that the anode connection for this thing is on the base, so, and I have no idea. Again, this side of the scope might just be storage or something like that, but just look at the size of it. It's absolutely enormous, and the amount of free space in here makes me think like this was an afterthought. Like there's an obvious glass seal here, like a it's been glass welded on a glass lathe, and it appears that there's a bubble that has formed in here as well. So it seems, I don't know, it seems like an afterthought or a prototype or a modified tube or something like that. It might even be a radar tube, and I have no idea. This phosphorus is about the same bluish, fastish one, so I'm not sure this could be a radar tube, considering it's a fast blue phosphorus, but who knows, maybe. So it doesn't even fit in the frame, and you can see the mesh barely through the glass there. Getters still intact, another beautiful piece of glassware. So I know calling it glassware is a misnomer, but it just looks like a plant pot or something like that. It's absolutely stupendous. Oh, and the socket for the other one is remarkably large as well, so you can just think of, like, not all the pins are used, evidently, so there's like 2, 4, 6, 8, 10, 12 used pins on the base, and you need another 8 pins to drive the deflection plates. So yeah, and I'm pretty sure that they didn't bring the deflection plates connections to the base, not because they didn't have room on the thing, but because it would have added extra capacitance, or it would have made it very difficult to, you know, get the wires through, and it would have probably made it very difficult to assemble. And yeah, so I don't know. I don't even know where the join is on that. The joint between the thing is, I'm pretty sure that the base of the tube comes you know, pre-terminated with the glass to metal seals, and they just stick the bottom on the tube, and then they weld the rest of the spot weld the rest of the assembly to it, and then they just weld the glass and evacuate it through the bottom. There's got to be a nipple, an evacuation nipple in the bottom of the stem there. You can't really see it because maybe you can now, but yeah. Oh, and there also appears to be another seam around here. There's a raised section, and there's a giant mica, it looks like mica, insulator and cable guide, wire guide in there in the bottom. It's just astonishing. So wonderful display piece, and just a beauty, a Bonnie and a joy forever, to quote somebody else. Right. Another thing that I found recently was an explosion detection device. Actually, I found a methane detector. These are Romanian made for the mining industry, and it's a very hard to read because it's all white and white writing and everything, but it claims to be IP54, and the measuring thing is IP44. If we take this off, you're gonna see one of those sintered bronze sort of, it's like the pneumatic exhaust for pneumatic systems. It's the same kind of material. And let me just turn it on to show you what it actually does. I have the back removed, so it makes it more educationally friendly. I think it wants something like 4 volts and quite a large amount of current. It used to have a Varta rechargeable battery in it, a nickel cadmium or something like that. You can see 2 lights lighting up, and it's counting. So there's no methane, and I don't have any lighters around to test it. But you can see there's some power supply here. There's a transformer with one of those pot ferrite cores, and there's another board in here. So I think this is the signal conditioning for the sensing element, which is kind of like one of those MQ type deals, and there's a basic ADC implemented on the bottom board. Actually, I have 2 of these. I'm doing this in real time with one hand. I'm unscrewing them, the screws, taking the thing apart, and talking to you at the same time. And now, ta-da! So this is the integrator capacitor. I've checked. This one doesn't work, sadly. So this is the signal process front end amplifier, whatever. I think the way this thing works, if we look in the cell itself, there's 2 elements. One of them is covered in a white substance, and one of them is covered in a dark substance. I'm pretty sure that one of them is covered in a catalyst, and you run a constant current through them, you heat them up, and because there's only 3 wires, and one of the wires is between them. So let me draw you a quick schematic of what I think is actually inside here. So there's a sort of bridge-like configuration, and you run a constant current through them, you heat them up, and you measure the voltage here. And when, let's say this one or this one is the variable one covered in the catalyst, when this gets hit with CH4, it catalyzes the reaction of CH4 decomposing into carbon dioxide and water, using the oxygen in the atmosphere, and it will make it go hotter, which will increase its resistance, which means that the voltage here will rise. And by measuring the voltage rise, you can get a pretty good idea of what the concentration of the methane is. They have some pretty loose specifications for the thing. So it's 2% error, and it's between 0 and 3% measurement. So it measures from 0% methane to 3% methane in the atmosphere. And yeah, not very... I mean, it's pretty interesting. These were probably manufactured in Romania, the cells themselves. The only thing that is Western is the Varta battery that was in here. And if we take a look on these sides, it's something that you'll never see on a anything other than a Romanian piece of personal protection equipment. So these are the terminals that are connected straight to the battery. And there is a diode in the series with this terminal, so there can't be any current flowing backwards through here. So if these terminals touch something metal, it won't spark. But that seems like an insignificant amount of protection for a device that can potentially operate in explosive atmospheres. Right, and I have one more thing that I want to show you. Along the same lines, I have to just go and get it. I'll be right back. Right, so we looked at a methane meter. We're gonna look at an explosimeter. So this is it's the same thing. Basically, it's a volatile gas measurement device. It's also made in Romania. It says that the device must always be inserted in its pouch. It had a rotten leather pouch, and it has some Allen screws here, which I have unscrewed previously to have a gander in the device, so I'm not completely unprepared when I talk to you about it. Oh, by the way, I got one of these mats for working on and soldering on, and I have to say they're pretty good. It kind of stretches out a bit when you solder with hot air on them and when you use hot air gun, but it seems to come back to its original shape. So, oh, I nailed it. So this is a 5mm Allen key right here, and in the bottom there is a NiCad 10 amp hour 2.4 volt battery. So it's a single cell NiCad, and correctly wired with the green and yellow grounds the lot. They're solid copper, like single core copper wires. And if we take it apart a bit further, if I can, I remember it being tricky, but not this tricky. There was something holding it in, but I don't remember exactly what. Oh, another 2 screws from the top, which I had loosened but forgotten completely about. They are hanging on by a thread or 3. So this is much less interesting. I think this is just a bridge circuit, and it's got a moving needle meter, and air or gas or atmospheric air is supposed to go through the chamber, and it says forbidden, do not open. I'm not entirely sure why. There might be something radioactive in here. I'll be right back. So I brought in my trusty Pripyat, which has a brand new beeper, and I'm just gonna do this and make sure there's nothing waiting to get out. I think the forbidden to take apart is just to, you know, prevent you from invalidating the calibration. Which, again, I don't want to take any chances when it comes to stuff like this. Very poorly made screws. So there's nothing radioactive, and that's not asbestos, which is good. Not entirely sure how to take this thing further apart. I think I'm just gonna ask you to give me a couple of minutes because I don't have any angle to approach this, and I'll be right back with it opened. Right, so there isn't anything radioactive in here, and after a cursory glance we can see there's 2 very similar looking cells, let's call them cells, and there's a mesh on top of them, and there's 2 of the same elements as in the previous device. They're just in separate chambers. What happens is gas flows through one, it sets the reference temperature basically, and then it flows to the other, and depending on the concentration of the volatile organic compounds, it catalyzes them and burns them, heats up the element, and makes a difference reading in what is basically a whetstone bridge running off a single 2.4 volt NiCad battery. So there wasn't anything dangerous, there wasn't anything you know, it says using VACUM sensors. VACUM means they had some weird stupid acronyms back in the day. ICE usually means Întreprinderea Centrală, which means central factory, and chemistry, and CCF, I have no idea what that would mean. It says that it's made in Romania, and it's made at CMC Otopeni. Otopeni is a city next to Bucharest, famous for the airport. So yeah, and that's I have no idea what the reading should be. Percent volume, it's pretty easy to understand, and the battery reading. So now, because I've taken out those things, you can see that it's, but there's a bit of charge left in the battery. So oh, one interesting detail, I'm sorry if you didn't see any of that. So the battery still kind of works. There's a couple of zero adjustments, and you have to pull on the knob to engage the the potentiometer. So yeah. All right, so that's about it. Short video, and at least in my definition of the word short. I hope you found it interesting. I do have a bit more of these artifacts that I haven't tackled yet, and that I plan on showing you guys. But that is for a future video. I'm going to try and take care of the dispute between an FFT on an oscilloscope and an FFT on a Fourier analyzer. So that's about it. Thank you for watching and have a good day.